I think. Okay, I think it's much better now. Thanks for that. Yeah, I can see it in my control panel, so I think it's fine on YouTube. Let me just check. Yeah, okay, cool. So I was talking a bunch of things before. Essentially, I'm starting a new repository to start this series of like building Reboot live and doing it properly. But I already have a repository, so I'll just move some folders and I'll explain why I'm moving those folders. So first, I'll put all the Motoko files inside this source folder, and let's straight start with the dfx.json. Hey, hello everyone. So let's straight put this. So this is my previous dfx.json. I have internet identity installed on the previous project, but I don't need it for today. I have a website as well, but I don't need it. And I have two canisters. The first one is the God canister, so it's like the kernel of Reboot, and I'll explain what this does and why is it useful. So I'll keep this one, and I'll also keep the player, which is the code for our canister. I'll remove that. This is actually cool, but I don't need it today. And I'm also planning to use mops. Mops is a package manager from Motoko, so I'll keep the mops sources here. Okay, now I'll just, yeah, so this is my kernel, so the God canister. I have already a lot of code for that. But actually today, as I want to start from scratch, I will not, I will not copy that. So, well, I'll do just a folder for it and the player as well. And then just one Motoko file for each. So core is actually the old name that I gave to the player, but now I'll just rename it to player. It's easier to understand what it is. Yeah, and for now I just, actually I'll just copy this one exactly. We'll need some parameters later, but for now just keep it like this. Okay, so I have my two canisters, and I'll just copy the git ignore as well. Okay. This one we don't need. This one we don't need. Yeah, the package we will actually not need it today, because today I'm not planning to work on the website, just on the backend. So actually that's pretty much everything we need. Yeah, I have much more things in my private repository. Like you can see there are some location. I've experimented with implementing some world location, some of them like library, academy, and all those stuff. I have experimented with implementing object in Reboot, and I have the website that I've been making really good progress on it. But yeah, today, as I said, today the objective is not the website. The objective is here. Set up the first repository, and I'll push it to GitHub so you guys can follow. Yeah, you can follow right now live, or you can also follow later if you're watching that later. And then I will work on my problem of the day, which is how do I implement the reboot ledger. So we'll go straight into it. Okay, I'm into generative AI, building AI agent, and I'm super curious about the ICP ecosystems. Any tips on where to start, who to follow, or cool opportunities? Hey, yeah, so you're at the best place to learn about Motoko and the IC. It's here. We do Motoko Bootcamp. I've been pausing the bootcamp for a few months because we are working on this really cool reboot project. But the bootcamp will start again next year. So you can join us next year. We have bootcamps, and we will have bootcamp every month. And it's not like a traditional bootcamp in the sense of like you come and then you do 1 week and then you leave. The Motoko Bootcamp that we offer and provide, it's an environment for you to build together. So you join, you work on your project, we help you, and you also help the community. And we have this environment where we can collaborate together. So that's actually one of the big things for 2025. You're at the right place. And I'm working also on making more like tutorials, and this is also why I'm doing this live session, to show how I work usually and you know what kind of problems I'm facing right now. And yeah, of course you have the, let me just show you. I mean, you probably already know, but I'm doing my own advertising. So you have the bootcamp website, even though we are pausing the live bootcamp at the moment. So the next one will be in 2025, the full bootcamp. You still have access to the self-study option, and it's a really good course. I'm doing my own advertisement, but yeah, I put a lot of time into this course. You basically build a micro DAO from scratch in Motoko, and you basically learn the basic of Motoko. So it's really like getting started. It won't take you to professional level, but it's it's a good start. And you have actually each like of those projects have a video associated with it. So, but it's changing so fast. Like the space is evolving so fast that I want already to upgrade this course to the next level. Okay. Let's open up GitHub quickly. So yeah, I have already created this repository. Let me just rename it. It's the second time that I do that actually. So this one will be the old one, or like, yeah, old. Okay, and we have a new one, so reboot. We'll make it public. And that's it. What happened? So, oh yeah. Okay. Okay, so we are really starting from scratch. Okay, let's go. I want to open Miro. It's a great tool that I use a lot at the moment. I'm starting to use it a lot. We used it this summer as well. In the Open Internet Summer, we used it a lot. So, reboot ledger. And here I want to try something. Open up a frame, and I want to see if I can draw from my tablet. It would be amazing because sometimes drawing is just so much easier to show stuff. So let's see. I need to connect to the account. Okay. Nice. Okay, I have it. That's weird. Okay, now it's good. So what is the problem? So today I want to work on how do we implement a ledger on ICP. And actually, it's not an easy question. It could look like it's really easy, you know, like that's one of the first contracts that you can do on any platform, any blockchain, like building a token is the basic for almost every project. And on the IC, we have, if I look at ICRC1, we have already a standard. So ICRC1 is a token standard, which enable you to create a token on the internet computer. And most tokens actually follow this standard already. So why do I want to, ask myself this question? Well, there are some problems with the current ledger, like how it is implemented. So if I look at ICRC1, essentially it's one ledger contains all the states. So if I do like a drawing, and I'm not the best at drawing, but that's like the community and that's the ledger. So yeah, that is a canister. Here, oops. Okay. Every time we will want to make a transaction between all of us, what we will do is like, okay, here I want to make a transaction, here I want to make a transaction, here, and imagine that now we want to implement like a notification system. Like we want to say, okay, every time you receive token, we want to notify you, or like every time that a transaction of a specific like amount, then we want to maybe ask you before triggering the transaction. Well, we want to, upgrade the ledger and add more functionality around it. It's really hard to do it because we will have to modify this canister every time. So here you have all the transactions that are validated in this canister. And you can quickly understand, like, when we are building decentralized systems, it's not a good idea to put everything in one piece, one canister. Right now we are doing it, and it's actually alright, I would say, to some level, because we don't have that much transaction to deal with first, so one canister can process all of the transaction. But actually, even at the moment, there is already some people that have thought about the limitation of like what it means to build everything in one canister. And so I'll want to show you. I think it's like 10K. Yeah. So it's an improvement that I was made like 1 year ago. It's a high performance ledger. So the idea was to implement a ledger that can process 10,000 transactions per second, which is much more than what one canister can do. And to build that, they've developed a multi-canister architecture. Yeah, and to be honest, I haven't looked into their code, even though I want to say that those guys, the research AG, it's a group of developers. They are doing really good package for Motoko. So if you see like a package with a research AG, that is the creator, for example, vector or streams, enumeration, you can be almost 100% safe. Like, it's a package that I recommend. You can use it because, I mean, they know what they're doing. Timo is one of the brain behind ICP. He was there from the beginning. So yeah, can definitely recommend their work. Anyway, let's go back. So ICRC1, I'm not satisfied with it. It's great to move forward. Like, I'm happy that we have it in the ICP ecosystem, and actually I want the reboot and boot. So we are implementing the boot token, which is also the reboot token. I'll explain that later, but we are implementing a ledger today, and I want this ledger to be compatible with ICRC1 eventually. But that's for like the outside. Inside of reboot, which is this new architecture and framework that I'm building, we are building it on the IC. The ledger will be very different, because what I want to have in the, in the end, like, version is a Bitcoin-like ledger. So if you look at Bitcoin, it's the complete opposite, actually. Let me just, how do I select everything like this? Maybe, yeah. Oh, I need to move here. So I'm out of battery. Okay, so I can't use that anymore. Yeah, I'm still learning how to use this tool. I feel it can be much better than how I'm using it right now, but I'm a beginner. How does a Bitcoin-like ledger work? So completely opposite, actually, because each like person, I think I can lock that and I can copy it. Yeah. So it's the complete opposite system, because you don't actually have one place where the transactions are validated or take place. There is just a bunch of people, and those people, they decide that they want to do transactions. So they broadcast transaction like, hey, I want to send like 10 Bitcoin to this person, and I'm just broadcasting that to nodes around me. But in our case, the nodes, we are the nodes, so we are the players. So the idea that I have in mind is that, why can't we, reproduce that type of architecture on the IC? Because if we do that, we don't have one ledger where it's like kind of centralizing all the state of who owns the boot token, where, what transactions are taking place and everything. And it's not just that it's better because it's decentralized. It is better because it's decentralized, but it's also much better to build like additional functionality on top of it, because if you are basically handling the transaction that are related to you, it's much easier to build functionality on top of that, like to basically add some functionality specific to you, where you say, I want to be notified by email every time I have a transaction that is more than 100 ICP, I want to be notified by email every time someone will send me money, or like even if you have automatic subscription, you can like configure everything, which you can't do, or it's much more difficult because if you are processing the transaction in one ledger, not everyone can like send their settings to this ledger. I mean, this ledger is not able at some point to know about all the possible settings of all the players. So yeah, Bitcoin, in the Bitcoin world, there is a ledger that is like the blockchain basically, and this only happens to be an emergent property of the network. Like, it's not that there is a blockchain and that people interact directly with the blockchain. It's more than there is a network, people broadcast messages, and then they use the blockchain at the end. But the blockchain is stored everywhere. So you have a copy of the blockchain, you have a copy of the blockchain, and everyone has a copy. The only problem is that Bitcoin is not efficient, because then you have to store, all the state of all the transaction, even the transaction that you don't really care about because it's not really relevant to you. So my idea is, how can we build like a middle ground where, okay, we are using this type of pattern, but at the same time, we are not storing the entire blockchain. Like, each player is storing maybe a little piece of what is relevant to them. So yeah, that is the idea for the ledger that I want to see built for Boot eventually. But this is a phase, like this is a project phase by phase, and I'm not convinced that we can reach the phase, like this phase, tomorrow. So I want today to actually write a document, and I think I'll use the ledger.md. Okay, so building a ledger for the boot reboot token. Problem: traditional ledger implemented on the internet computer, like ICRC1, introduce a centralization component in their design. One actor / canister is responsible for handling and storing all of the transactions broadcasting transactions to close nodes in the network is not possible. Question: is it possible to implement a Bitcoin-like ledger on the internet computer that is more performant than a centralized standard ledger? Yeah, I'm doing it because I believe that eventually this design is more it's much harder to build because we don't think like this. We don't think in terms of broadcasting like an event in the network. We think like, okay, there is a ledger somewhere, this is the canister, I just make an inter-canister call, and that's my transaction. And eventually this ledger should actually look like this for developers. Like, we shouldn't have to, when we interact with this protocol that we are building, we should abstract it away and it should look exactly like how it is right now, essentially, in terms of facility, like easiness of development. But we have to design this protocol and we have to think how how this can be made, and how this can be made in a very performant way. So is it possible to implement a Bitcoin-like ledger that is more performant than a centralized standard ledger on the IC? And probably, I don't know if these schemas are enough to make it clear. Okay, phase. So phase 1, phase 2, phase 3. Yeah, also maybe like we can ask ourselves what are the functionalities that we actually need. So transfer of tokens, actually, so boot and reboot are the tokens that we have to take care of. Metadata and information, that's important, accessible for like exchanges, display of balance and information. Blockchain. We want a blockchain for the ledger, so we want that anyone that comes later is able to trust that the current distribution of the token is in line with the initial parameters. Like if you look at Bitcoin, you can go back to the first transaction and you can actually say, okay, yeah, like all of the transactions that have taken place, they have respected the protocol, and I can trust that. Right now with the ICRC token, you can't really do that, so that's a problem, because someone is controlling the ledger. If you want to upgrade it, someone needs to control the ledger. And if someone controls the ledger, then how do you make sure that no one can take token or like change the state? I think you can basically keep the control of the current implementation, like how transactions are handled, so the protocol can evolve, because we are not gonna get it right from the first version, that's for sure. But at the same time, you can build the blockchain, and those blocks, they are just stored in a canister that is black-holed. So leveraging a black-holed canister. And if you do that, then you can be sure that all the blocks cannot be modified. So we can kind of replay the full story, and we can trust that. We want also be able to stacking of tokens, subscription built in, subscription functionalities. This is really important for the reboot ecosystem. This is something that I want to explain later, but there will be a huge aspect of subscription. This is how we can make services and create value with subscription. And stacking is also very important, so it actually needs to be built in from the ledger itself. Like we need to be able to stake inside any canister in the network. We want to be able to stake in any entity of the reboot network. And we want to be able to subscribe or reboot our tokens to any entity. This might be a little bit confusing if you are just learning about those tokens, but yeah, let me know if you have a question. I can answer it. Okay, implementing the fully decentralized ledger is a massive challenge, and we need these functionalities before we can build the perfect version. So yeah, we are building the, everything is a chicken egg problem where you need some aspect of it to start it, and at the same time you need you need to start it to be able to improve it. So we need to start, and I think that phase could be good. So phase 1 would be similar to traditional ledger. I mean, maybe phase 0 would be actually better for that. I'm saying centralized because it's centralized in the architecture, but it also, I mean, slightly more decentralized than everything else because it's a canister, so it's on the chain. Similar to a traditional centralized ledger where one canister is responsible for handling transactions, all the transactions. ICRC one, like. Phase 1 would be slightly improved. Phase 1 would be, let me think about phase 1. Okay, I think it would be like transaction are so transactions would be processed locally between receiver, sender. So for example, if you send tokens, you would deal like the state change would apply to the person that receive and the person that send. But centralized ledger would regularly sync the state and provide a single source of truth in case of divergence. Yeah, I think that would be, so maybe we can rename it. I think there will be only 3 phases. So that's essentially still, we still have a ledger that is the end, like the person that is, the entity that is responsible for the final decision on what is the state of the distribution, like how tokens are distributed. The state would be in that ledger, but we have already implemented, in this phase, we would already have implemented a way for transactions to take place without directly sending a message to the ledger. So people would actually be able to send tokens without interacting with the ledger. They would just regularly sync their state with the ledger. And if there is any like discrepancy, that would be probably something we want to monitor. And that would be always the ledger that is the responsible, the single source of truth. And the phase 3 would be transactions and the blockchain are emergent properties of the network. The ledger is only, well, we have monitoring and user is fully decentralized, and each node / player is responsible for handling their transactions. We have monitoring in place, and even compatibility with previously established standards like ICRC1. The performances are speed of transaction and reliability of the system are above what could be expected from an ICRC1 token. So yeah, we want to also keep the performances. I will just ask my friend Claude to improve this writing just to see clarity and provide some critiques and additional questions for my ledger project. Okay, so I'll just copy that. It's pretty good. Actually, I don't need at this point this. I mean, that's nice, but that's not necessarily the priority. Okay, so yeah, I'll just leave that just with this to make it clear it's separated from the rest. But that's actually interesting questions. But we will answer those questions later. Now, I'm gonna move directly to phase one. So even though those problems are very complex, I've learned one thing is that we need to move very small steps at a time. Too many times I've tried to solve those problems and it's too hard to solve it in one go. So the idea here is just to be able to do transfer, staking, and subscription, which is already a lot of work. So yeah, let's go and let's do it. So I will define the maximum amount of token that we want. So private let maximum supply, which will be 21 million, like a famous 21 million, like a famous token. Yep. And then I'll define a ledger, which would be very easy to, like the simplest ledger that we could build, which is going to be and now I need the MOPS package manager. So oh yeah, first we need to do MOPS init. So I have MOPS installed on my computer, but if you don't, of course, just go here and install it. And you also need to configure your dfx.json. No. Okay, and now MOPS add map. So the map is a package that is stable, which is great. So stable means that when I upgrade my canister, I will not lose the state of the variable. So I can just use my variable like import map. So it's Motoko map /map. And then I can just use it like map.map. So it will be a map where the keys of the map are principal and the values will be nat, so basically the balance of it. And map.new. Yeah, and I don't think it can be public. It can just be, no, yeah, it cannot be public because it's not shareable type, but that's fine. So yeah, that's how I'm going to store the balance of everyone. And yeah, I wanted to say that it's a stable variable, so if we upgrade the canister, this will not disappear. Okay, now let's implement the simplest method we can do. So let's say transfer. So transfer, we want a from, which will be a principal, a to, and an amount. And then, so this is async nothing because I don't want to return. For now, I really want to keep it as simple as possible, and I don't want to return the result of the transaction. I just want to do it. Okay, so I'll need to get the option type. Let from balance is option.get map.get principal nat of the ledger. And yeah, I just need to verify something. Yeah, so I need to pass the map to this method. I need to pass the hash utils. So hash utils is actually a method that we need to import. This ph is just a hash method on the hash utils on the principal type. So because we have principals as the key. And then my actual key is from. Oops. And yeah, so I have two methods. I have the map.get here, and then I have the option.get, and the option.get it's here that we can find the documentation for it. Where is it? That's weird. Yeah, Motoko base library. Option. Option.get, it's enabled me to, because here I get an optional value and I want to move it to a non-optional value, but in case the person doesn't have a balance, we put it to 0. So that makes actually a lot of sense. If you don't have a balance, you have a zero balance. And I can do exactly the same for the to balance, just changing the key to this one. Okay, now if the well, that's almost, well, that was almost good. If the from balance is below the amount, yes, we want to do that. But that's not the correct syntax. We want to do map.set and map.set. And then otherwise we can throw an error, which would be error. No, that's not it. it's here. The error module, it's that's weird. I thought we had the throw. I think we can just do throw like this. Ah, yeah, throw, but then we need to put a message. So error.message. And the message. Okay, like this. What? Ah, no, it's reject. We need to use the reject. Okay. So we have our transfer method. We will also want to have a mince method. So to create some token first. And this is a good start. Actually, it's a good start because we have the, yeah, we just, anyone can mint token. For now, we can authorize that. And then we just exceed the maximum supply. Otherwise, we just create token. Okay. And maybe another method that we will need pretty quickly. Yeah, we can get the balance of anyone. I think what I want is more like this. So if you call this, you get your balance. And that's pretty good. Oh yeah, something I did not verify is that we would want the we would want to verify something, which is that the coder is the from, because otherwise you could transfer for anyone. So we just do that, and if that's not the case, so if that's not the case, our canister will trap and we can just skip it. And then, I mean, this one we can leave it open. Okay. Well, we can deploy that first and see how that works. Starting a replica. Whoa, already 1 hour live. Okay. Okay, so we can deploy good. So if we think like operating system, this is our kernel and this is the programs that are running on the kernel. Yeah, if we think like Linux, this is the kernel and this is the program. Okay, so it's deployed. we can test some basic functionality. I don't know if we can use the login method. That would be nice. Doesn't seem to work. Okay, my balance is 0 for sure. I'm using the anonymous principle. So what I will do is yeah, it's much more interesting to use a player. So we can do that. Yeah, I need some code here. Okay, so the player, I need to explain how the player works a little bit. The player is very simple. The player has just one action that he can do. And where is it? Oh, it's here. No, actually it's here probably. Wait, that's weird. Ah, it's here. So I'm copying some code here from the previous reboot implementation, but okay. So the player do everything through the play interface. The only other methods that he has for now, it's just a start method and a stop method, like when you start your computer and when you when you start your computer and when you turn off your computer. And then everything else goes through this play method. And we need to basically, all the logic need to be implemented inside of this method, like every single action that we do on the network. But I will explain how this goes when I do it. Enter principle. So we need to, so we have 3 argumentation parameter for the player. When we actually deploy it, we need to pass the God principle, the admin. So the admin is who is able to use this canister. This is going to be your internet identity, for example. Your internet identity, or DFX also. And the name, we just store the name, and actually for that we need the identity module. So identity stable var name, and I don't think I can do that. Okay, so let's just save this file and redeploy it. So the first principle that we have to pass is the principle of the God canister, which is this one, this canister ID. The second to be admin for now, so this one. And the name, it will be my name. Okay. Just 1 second. Okay, so the player is deployed, and now we can test the ledger. But for that, we need to define something first, which is going to be the action of the player. And yeah, let me explain how the player works. So the player is supposed to do everything through actions. Do I have it somewhere? So yeah, that's an example of like what is an action. So an action can be a movement, it could be a report, it could be an interaction with another entity, but anything that the player does is an action. It's part of the game. So it goes through the play method and it goes through this action system. So public type action. And here we have just one action, which is transact, I guess. For now, the transacts are going to be handled by the ledger. And maybe we want to define what is a transaction. Yeah, we will want to do that. So transaction. And now what is a transaction? Well, a transaction is can be like very different. We can have a transfer, and a transfer is a transfer. So it's of type transfer, and then we need to define what is a transfer. And we can maybe have a mint, which would be a mint action. And we have the stake, which would be a stake action. And let's keep it simple for now and not do the subscription so early. Actually, let's keep it very simple and just do the mint and the transfer. So what is a transfer? Well, a transfer is an object where we have a from, which is the person sending. We can send it the sender to, and the amount. And for now, of course, all the transactions that take place in the game are going to be with the boot token, so we don't really need to specify any ledger or anything. We don't need to specify which token. And the means, I mean, there could be a lot of information here, but let's just say to and the amount. This can evolve, of course. We can come back to those types, but for now, let's keep it simple. And you will understand why I'm doing like, you know, there is a reason why I'm doing this that way. Action, transaction, and then what is a transaction? Okay, there is a transfer and a mint. That is all part of the reboot type of building. It's more work in the beginning, but it gives us a nice way of like working together, and because those types you will be able to use them in your code as well, because all of them will be part of a module that will be the ledger module. Okay, so when you play, you send an action, and when you send an action, it's of type action. So for now, if you are booted, so if you are on, you will do the action that you send. And we also need to assert something, which is that the coder is an admin, and because we don't want anyone to be able to play for us. Okay, so this, we can actually bring it to inside one line, so that will be a little bit cleaner. Then we switch on the action, and depending on what the action is, we can, oh, 1 second, yeah. Depending on what the action is, we will treat it differently. So here we have only one type of action, which is a transaction. Well, transact. And well, for now, I'll just do, yeah. When you send a transaction, you have inside of it, you have the actual transaction as we've defined it here. You're transacting. This is really kind of stupid for now, but just to show you the idea. But imagine that we want to implement other action. Well, it's really easy. The only thing we need to do is define what this action is. So it could be a movement, like movement, could be interaction, like moving, I mean, entering into a building or entering into a car, anything. But we need every time to define it in the type action. So the type action will be, yes, it will be a lot of variants at the end. It will look like, you know, probably 20 different actions. And all of them are taken care inside this play method. Okay, so I just, let's say move, output move, and we don't really need to define it for now. We can keep it like this, just to say that there is another, you know, all of the rest, we can return an error, not implemented yet. So this is not implemented. The thing that we have implemented is the transaction. So the transaction, we should be able to take care of them because we have implemented them here. So we can take care of that. And so the action can be a transfer or a mint. For now, we are going to put all the logic here, but you will see later in the stream that we can actually use a module to take care of all the, you know, all the possible case. So we don't have to write all the code here in the main file. But for now, let's do it here. So we are going to define the ledger, which will be of type actor. So this is another canister, it's an actor. Public type ledger is an actor that can do mints and transfer. Actually, let's do transfer first. I will put it on the side. So transfer is a method that takes a transfer of type transfer and returns this. And now, yeah, it actually, I need to modify this a little bit to make it compatible. So just put the type here as well, and then transfer of type transfer. Oh, actually, we could do something better, which would be using the destructuring pattern. So it's like in JavaScript, to, from, balance, amount, and this is transfer. And now we can use the from and to directly. Okay, there is a question. Hello bro, I did the Motoko Bootcamp to graduation, but so far I haven't gotten any role. Does Web3 and ICP, to be specific, have any market currently? We are creating the market. Yeah, there is not a huge market like in terms of roles, because the industry is very new. So the only thing that you can opt for is finding a group of people where you can build a startup or build a project together. And find some funding for it. But there is not like one company that is going to hire you, like like Google would hire you, or more established company would hire you, because this industry is very new and the market is really small. But my belief is that the market actually needs to, we need to think in reverse compared to traditional industry, because in Web3 we can build together and we can actually create our own market. Like, we can get to a point where you don't need to wait for someone to hire you. You can just build your things and find a way to monetize it. That's what I'm trying to do. And otherwise there is not really a lot of like traditional jobs in the Web3, especially in ICP. But if you're active, like if you get your name out there, there is a lot of people that are ready to pay you to build for them. So yeah, depends on what you're looking for. But doing the bootcamp is a good start, but it's not enough. Like, in 1 week you cannot get to a point where you get hired. The bootcamp is just the start. Then you have to continue building and continue getting your name out there. Okay, so so we've done the transfer, and then I will do the mint as well. And the mint for that means and bond variable amounts, because we need to do the same here. So okay. So here, in case you're not following, I'm simply defining this actor, which will enable me to interact from this canister, from this actor to this other actor. And I just need to basically define the methods that I want to use. So the first method that I want to use is the transfer, and I also want to use the mint. The mint is like this. Okay. Okay, so let's ledger is of type ledger is an actor. So here we actually need to get the actor ID, the canister ID, which we can find through the Candid UI. So here I have it. This is the ledger, the God canister here. Oops. And now we have to switch on the transaction actually that we want to do. So in the case of a transfer, this will be here. In the case of a mint, this will be handled here. And here I will do a try catch because I'm calling another canister. And so when you're calling another canister, you can use the try catch, which means that if the other canister throw an error, which is the case here, it will not crash your canister. You are able to handle it. It's essentially the try catch like in JavaScript, if you're familiar, but it only works in asynchronous context. So it only works when you're calling another actor and not inside of your own actor. But here we are calling this ledger, so it's fine. Okay, so ledger.transfer and then transfer. And if everything goes right, I just return OK. Yeah, it's an await here. But actually, I can do something which is ignore await. This is no, we don't really need it. Yeah, because this is wait, there is something weird here. I think I want to just keep that because here it's still going to await. Let me just take note of that. So. Okay. I'm just modifying the type of my return type, so it's just going to be OK. The move has worked. Otherwise, we are going to return an error. And we don't actually put anything to the user, so I will explain how we can interact with the actual user, like how the user will know that all of this worked. You will see. I will use kind of a pattern that we can reuse for all the methods, not just for one method. And then we can just do the same. Ledger.mint. Return OK. We might want to later add some type of log so we can actually log the error and we can learn about it. For now, we are not really using it, so it's actually throwing like a warning. Let me see. Yeah, it's saying that it's unused identifier, so I should rename it to this. This basically means that we don't really care about it. Okay, now the question that I ask is, how are we going to interact with the user? Like, how does the user know that when he's playing, he has some, return on the state of his player? We are going to use a state variable, which is going to be a text. And the state by default is this, waiting for your next move. So that's the state. And we can actually, at any point, query the state. So we actually want to maybe call it player states because it will be a little bit more clear. Player state. And just returns the state. What? Public actor field needs to be a manifest function? What do you mean? What does it mean? It's the first time I see that, actually. Okay, I understand. I just forget to give it a name. Get state. And we want that only only the admin is able to check it. And actually that gives me a good opportunity to I realized that this is actually kind of the same. I mean, this is the same. We are just looking at the state of whatever the canister is doing. So we can actually rename that to states and can say player is off. When we start, we are going to put waiting for your next move. And state player is off. And now we had this booted, but then, I mean, we are just gonna, we don't really need it for now. So yeah, let's do it. Now what I want to use the state for is that every time we finish something like this, we can do states and we can say you've just transferred, you've just made a successful transfer. And we could, you know, we could be more explicit, like we could actually read all the parameters and say you've sent that much to this person and so on. But for now, we will of course keep it simple and we just say you've successfully minted goods tokens. So I don't know if you start to realize, but this actually makes the player is the only like person that is responsible for the entire state of his game experience. So the game is, you know, you are playing your own game. I mean, the player is playing his own game because of course he's interacting with the ledger, but any state change take place inside of the player. And this will be the case for more and more things as we move forward into Reboot. Every single state change will take place locally. You will take place inside of your canister. And that's kind of the only way to do it properly. Let me see. Yeah, so I need to reinitialize my canister. The fix canister ID. This one. And then my principal. And then next one. It's my name. Okay. And now if I just go here, yeah, the only problem is I will not be able to play from the Candid UI. Well, I can see my state here. No, I can't actually because I'm not authorized. Only the admin is authorized. So yeah, we have to use the terminal for now. The fix canister cool player get state. And that's not the correct. That's not the correct code. It's here. Cool player get state. Okay, the player is off. So I need to start my game. My player, the fix canister cool player start. Okay, we started. Now we can check our state. And you know, you can imagine that this is constantly being shown to the user on a website. Like he can see that, and so he doesn't have to query this function every time. Okay, so now waiting for my next move. Okay, so what do I want to do? I want to do the only thing that I can do for the moment in this game. The only play move I can do is transfer or mint. So I will do player, play, and mint. Let's say mint. Well, it's actually a little bit complex to. Oh no, okay, thanks. We have this this interface. Okay, so what move do you want? Do you want to move or do you want to transact? I want to transact. What do you want to transact? I want to mint something. Who do you want to mint for? I want to mint for... Nope, I want to mint for myself. So this time I need the canister ID of the player. The fixed canister ID player. This one. Okay. How much? Let's say 1,000 token. And we have an error. So there is something that we didn't catch. Yeah, the problem with our results is that we don't have any information on the error. So let's go back to this. And we need to import the AR module. That's pretty annoying to have to do it every single time. That's why last time I had a init file, and actually I probably can do it again if I find it. That's weird. I think this one maybe? No. Well, yeah, no, that's, well, I have to do it. Okay, and I want to deploy the ledger once again. Okay, let's check the state of the player. The fixed canister player call get state. The fixed canister call player get state. Okay, it's a stable variable, so we are still on. So waiting for your next move, and then play, transact, mint. I think we had it here, but yeah. Okay, 1,000 token. I think like this work. Okay, so this time it worked. I think it's because I did not, yeah, I had not I hadn't redeployed the ledger, so it was not the right types for the function arguments. So now it's fixed. Okay, so now I can check my player, and it's saying I've successfully minted boot token, which is actually the case, because if we go to the ledger, if we go to this method, if we say get the balance, yeah, unfortunately we can't check the balance of I'll just do that, get balance. Yeah, the problem with this method is that it only gives you the balance of the person that is calling, but I am calling from the DFX and not from my player, so I will not get the right amount. But I can have balance and get balance. I think that's totally fair. So we just need to redeploy. Get balance, and then we put the principal, or not, actually we can use the CLI. Yeah, that is the principal of the player, and we should see 1000, and we don't see that. So is it because it's not stable? Ah, yeah, I forgot to declare it stable. So that's why we have 0, because I redeployed it, but I'm pretty sure it's working. I mean, we can test it again. So if I do again player play, transfer, no, actually it's not a transfer that I wanted to do, it's a mint. And that's it. It works. So that's really like basic. We haven't done anything crazy today, but that's already a lot of progress. Really happy about this system. So now the next things we are going to work on is to actually wrap all of this logic inside a module, and you will see how clean the code will become, because now we have defined the types here, and we have defined the types here, and we have all this code that is here. But once we have put all of the ledger functionality inside the ledger module, you will see how clean the whole thing is, and it's actually very nice to look at. But I will not do that today. I will just stop from here. Well, actually, maybe I can come back later, but now I want to do a break. So, what time is it? Yeah, it's been 1 hour and a half. I think it's a good moment to do a break. Yeah, I'll do a break, and I'll come back in like 30 minutes or something, 40 minutes. Yeah, let's do that. Does it work? That's really bad. Looks really ugly, but we'll do with this for now. Oh, that's before New Year's. Okay, so 20. What does it correspond to? Time. What is it? Is it like... Ah, okay. It's when. Okay. Yeah. It's a long break, but I'll be back.